Now, like classes, arrays are going to be almost always instantiating using the new keyword. So for strings, we saw you don't have to use new. With arrays, it's going to be new most of the time. So there's 3 notations for defining arrays in Java. And the first here is just a simple creation of an array, but not specifying the values that go in an array. So this first syntax has the variable y, which I'm assuming has been declared earlier. I want to put in that 64-bit box the address of an array I'm now creating. That array will consist of 3 boxes of 32 bits each, along with a length 3. And Java, when you create an array, it will get a default value. And we'll see in the visualization what that means exactly. And the other kind of notation, or sorry, the second type of notation, is to say x equals new int, and then here have the actual values you want to put in there by default. So in this case, we're not explicitly stating the size of the array, but Java's able, it's pretty smart, figures it out. It says, you want an array of size 5, and it puts these default values, or sorry, it puts these values in instead of the default value. Okay. Now note that when you create an array in Java, you always get a default value. So if you say new int 1 million, it's gonna set aside 1 million boxes, and then it's gonna write a bunch of zeros if it's all ints. So there's a little bit of overhead associated with creating arrays in Java. All right, so next up we have our final and somewhat strange syntax. This one is just like the one above, except we don't do new int. And what's sort of funny about this is it only works when you're also declaring a variable at the same time. So if I say int bracket w, that allows me, because I'm declaring right now, to instantiate without the new int keyword. Why is it this way? I don't know. But that's something you could do. So if you like this notation, be aware that you can't use it with an already declared variable. And so each of these notations, they all do the same thing, right? They create an array which has some length and it has in boxes, right? Where in is the length. For those of you curious about what's happening under the hood, you might imagine that an array is, well, maybe it's 32 bits for the length plus k bits per box for a total of 32 plus k times in bits for an array. But it turns out that in typical implementations, it's actually a little more. I have a little note in the bottom right corner, and this is a reading in our optional textbook if you're curious, but not important for 61B. Okay. So let's work through an example. So this is an example where I think that you, given what you saw in Project Zero and in this lecture, you could do every step of this and draw a nice box and pointer diagram, except maybe this last step here. So let's run through this example, and you can follow along and try and guess what's going to happen. Now I'm going to set 2 options. I want this so that things look nice and we don't get weird. We did this last time, so make sure that it looks more like a box and pointer diagram. And I'm also going to enable this option so that strings show their true nature. Okay. So if you're curious, So if you're curious what these do, you can take them away and see what's different. But whatever. This is just so that the diagram it generates is consistent with our box and pointer notation. Okay. So the code begins. Int bracket z. What does that do? Well, that's going to create a box of how many bits? 64. And what goes in there? An address. Remember, there are only 9 things in Java types. There are the 8 primitive types, and then references to anything. This is a reference to an int array. So we get 64 bits, and into that array we write a bunch of zeros, okay, which we call null for short. Okay, so we have 64 bits here, all zeros. Now in the visualizer, we also at this point get 2 more boxes, x and y, which will be 64 bits, but the visualizer as designed by Philip Guo does not show those boxes, but you can imagine they're there. Okay. So we do x equals new int, we get our 64-bit box x, and we fill it with 64 bits. What goes in those bits? Why, the address as returned by the new function. Okay. What does the new function do? Well, it's going to go find some place in memory for 5 integers to live. Okay, here they are. So 32 bits for each one. And x is going to record the location in memory of this whole box. Now notice that the visualizer does not explicitly show the integer that stores the length of an array, though it does nonetheless exist, at least in a typical implementation of Java. So you can imagine there's a little 5 up here, but not shown. Okay. Now when I say y equals x, okay, what does this do? Well, we have this box over here that has 64 bits in it, and of course the thing you do whenever you say y equals x is what? Copy the bits, okay? Nothing else. So when we copy the bits, well, our visual metaphor says we should draw an arrow to the same object, and there you have it. Now we're going to take x, and we're going to replace these bits here with the address as returned by this next call to new. Okay, so this is again an array of size 5, and now x gets the bits corresponding to the address of x. Okay. Next we have y equals new int 3. And so what that means is we're going to throw away these bits and replace them with the address of a new array of size 3. Okay. So there's a couple interesting things here. One of them is that the visualizer is going to make this disappear. Watch. So it's gone, right? And it kind of reorganizes for us. But the array that's 1, 2, 3, 4, 5, it is just gone forever. We can never get it back. And that's what I mean by an object is anonymous. If we lose the reference, that's just it. We'll never see that array again. It's garbage collection. Okay. Next up, then the other thing that was interesting is that we got an array of size 3. And in this case, it's all zeros. Why zeros? Well, in Java, when you create an array, you always get default values, much like how with a class, as we saw before, you get a bunch of default values for every instance variable. Okay, so these are my default values, which for an integer is 0. This is just for fun. So when I run this line, I get an array of size 0. So there are no boxes and an int, presumably, that says 0 somewhere. And so z just points at this thing. If I want to get the length of an array, I can actually use .length. So you can think of it as an array is like a class in a way that has an instance variable, kind of, that is called length. And so when I say int xl equals x.length, it accesses this, yeah, this is x. It accesses the secret 5 we cannot see, and it copies those bits. Okay, so it had a 5 up here. We copy them. We have 5. All right. Now we have creating a string array. Okay, so a challenge for you to ponder. How many boxes get made? Okay, that one's probably pretty easy. And how many bits are in each box? 0? There's no strings yet. What do you think? Okay. And you might try and guess what the default value will be. Okay, well, I'll spoil it for you. What you get is 6 boxes, and each one's 64 bits. And each one can hold what? Okay, I want you to answer that question to yourself, awkwardly. I don't care if your roommate's watching you, whatever, and you have earbuds in. You're just going to say out loud your answer, and they'll think you're weird. Okay, string references. That's correct or not correct, depending on what you said. So what we got here now is 6 boxes, 64 bits each. They hold string references, and the default value is all zeros, which is null. So then we go to the box and we say, or we go to box 4 of this array. Okay, so S points at this whole thing. We say go 4 slots over, and now we're waiting and looking at these 64 bits, and we're going to assign them to ketchup. What is ketchup? Well, this is, we saw before that we can instantiate strings with quotes. So in this case, we basically call new secretly without seeing it. Oh, geez, without seeing it. And so what that will do is a new string is created, its address is returned, and our arrow points at it. Okay. How about this line? So I think that if you came from 61A, 61AS, or really any programming course, this I hope you can figure out. Okay, so try and figure out what's going to happen for this one. Okay. So Java, what it will do is this is not a value. It's going to evaluate each of these things. It needs to compute this difference. So it's first going to go to x3, 4. x1, 2. Then it's going to say 4 minus 2 is 2. So it'll go to s2, and it'll set this equal to the address of a new string, muffins. Okay. Next, we'll create an int array b. That one's not very interesting. It's just the same as we've done before. But now I have this extra little call, system.arrayCopy. I'll be explaining in just a moment. So what system.arrayCopy does, though, is it copies from array b to array x. And it starts at position 0 of b, and it copies to position 3 of x. And I find the syntax a little hard to remember. I always have to look it up every semester. But basically, it's going to copy 2 of those numbers. So in other words, starting from 0 of b, going 2 slots over, okay, these are the ones I want to copy, I'm going to go to this location and copy them here. So after I run that, you'll see 9, 10 appear up there. Okay, so that's basic array code. Let's talk a little bit more about array copy. So actually, the first question we ask ourselves is, why would we ever want to make a copy of an array? Well, it's not enough just to say, for example, y equals x, right? This just says I'm copying the address of an array from one variable to another. This is 2 references to the same array. Similarly, suppose we're trying to write a non-destructive array function that takes an array and, say, squares each of its elements. Well, whenever you give that function an array reference, it gets an actual reference to the original array. Okay, so I have a main, financial tax software, square. I don't know why you're squaring numbers in tax software. But anyway, I give my precious array, me, to someone else to go do squaring, and they claim to be doing it non-destructively. They better have some way to make a copy of an array. Otherwise, they're breaking my array. Okay, so if it says non-destructive, better be that way. Okay? So there's two ways to make a copy. One is do an item by item copy. Just write a loop. While I is less than x.length, y of I equals x of I. Okay? Now the alternate approach is to use array copy, and this function takes 5 parameters. So when I see system.array copy, it says copy from the array B, starting at index 0, to the destination array X, starting at X's position 3, and by the way, copy 2 of those. Okay? So in slice notation, if you know Python, it would be something like this, right? And if you've never seen slice notation, do not worry about it. So array copy, what's the advantage of using it versus a loop? Well, it's probably going to be faster, particularly for large arrays, because the Java interpreter is closer to the hardware. So it can take advantage of knowledge about how things truly work that you, as a Java programmer, cannot. The other reason is the code is a bit more compact. And if somebody knows what this means, it can be easier to read than looking at a loop. But one could also argue it is harder to read because you have to remember what all these parameters do. So I'll leave it to your judgment which you think seems easier to read.